First of all, to feed this, the concept is to use a ring of linear magnets.
Okay.
So you turn this magnet on, it grabs some grit.
Right.
There's a magnet right here.
Right.
We turn this one on and shut this one off, so the grit goes from this magnet to this magnet. So it's a series of magnets. This one turns on, grabs it. We turn on the next one, that one off, and it passes it to the next
So you're
magnetic field.
Cycling the grid.
Yeah, so we can just pass it from magnetic field, magnet to magnet, all the way around the grid. Now gravity does not influence.
Because the magnets are controlling
Yeah.
the grid. There's
Yeah.
nothing that's going to drop unless
Nothing
you want
that's
it to
gonna
drop. Right.
So when it gets in front, so here's our magnetic ring. So when it gets, we got a wad right here, okay? So here's the magnet's holding it right in front of our first solenoid. So we turn that one off and we turn it in, now we suck grit into our first solenoid.
Okay.
And our first solenoid is a holding solenoid. We've loaded the gun, basically.
Okay.
So we got a series of 4 more solenoids. Because theory is showing us, and you gotta remember this is all theory mind work right now, that's where you start with theory, right?
Absolutely.
Then you build it into the garbage and you find out what reality is.
Process of elimination and figure it out.
So what happens is, on a coil, when you turn a coil on, your magnetic field is like this. So the coil comes, when you turn the coil on, this one's on, we will turn this one off. Actually, we'll turn this one on. Then we shut this one off, and it'll pull the grit into the magnet.
Okay.
Now the key is, when the grit comes into the magnet, as it enters the magnet, it's accelerating. When it hits the center of the magnet, it will start decelerating because this part of the magnet's pushing the opposite way and is going to try to slow it down.
Okay.
So what we have to do is, between each solenoid, we put a sensor so we see it fly by.
Okay.
So we turn this one off, we turn this one on, it goes by the sensor, we turn on this coil. So as soon as this flies by, we shut this coil off before the grit enters the negative half of that solenoid that wants to slow it down.
Right.
So we turn it on, accelerate it through here, shut it off, this one's already turned on, so it's grabbing it, accelerating it, turning it off. We turn that one on ahead of time to grab it instead of.
You're creating, the more you do that, it speeds it up, speeds it up,
Yeah.
speeds it up.
And so far, theory shows you get to the 5th magnet, you're going to be going fast enough that any more magnets is going to be too inefficient.
Right.
But at this speed, we should be more than fast enough to accommodate the goal here.
So by the 5th one is when you blast out the steel, and because you're moving at that motion and you're constantly doing it,
Yep.
and it's self-feeding.
Yeah,
You're not
self-feeding.
losing any grit.
It's self-feeding with magnetic field, so gravity doesn't is not an enemy here.
Holy cow.
So the key is, we thought, well, we gotta shut this magnet and turn that one on. No. You turn this magnet on, shut this one off.
Right.
As soon as you shut this one off, this one's gonna grab the grit out of it.
Right.
And then as soon as it goes by that sensor, this one's already on, you shut that one off.
Right.
You keep pulling it faster and faster and faster. But you shut it off before you get to the negative side of the coil, which is going to start slowing that grit down.
Right.
So this is what Tom is prototyping up.
So he's building this right now.
He's getting the components in to start building this.
Wow. How long do you think it'll take him to build it?
I get that. I think he's on like a 2 to 3 week time frame.
Hasn't he already done a schematic?
Oh yeah, I'm sure he has.
Yeah.
These are questions for Tom. And when Tom is 70 years old, been at this for, he's an electrical, he's out there.
You're more, he's like you, but you're mechanical. He's
But I'm
electrical.
mechanical, I'm the creative guy.
Right. He's electrical,
He's the
electric guy.
electrical, he used to design for Motorola and stuff, when it comes to electronics, he's.
Sounds like you guys have a good mix.
Oh, yeah, yeah. So when he gets done with this coil, then I gotta design and build. And also what he's discovered is, right now I've got him blasting straight down.
Right.
Right now, he's saying we gotta be at a 30-degree angle, not straight down.
Okay.
Why, I didn't get a real good explanation on it. I'm sure he can tell you.
But with the way this is set up, so you're gonna be passing the grid around, it gets fed into solenoids, they speed it up, blast it on there, once it blasts, it drops into a container, you pick it up and do it again.
Yeah,
So it's almost self-sustaining.
this, yeah, will be, because this will all be enclosed with a little pan underneath here. So we're catching the grit we just blasted,
Right.
we're just gonna pick it right back up and send it through the system.
Nice.
So
So they'll never see the inside of this, they'll
This
get
will
a
be,
casing
this will
around
look
it.
like, almost like a tire around it, just a round enclosed thing with grit.
Then you'll just slide down the pipe, put
Yeah.
another one, slide down another pipe, and just, essentially, you could just keep it going.
That's the idea.
Oh.
So, what you see here, where is it at? So once we get that coil, what we'll do is, and see, that'll all be enclosed, and at the bottom, this will be all enclosed.
Right.
And at the bottom, we'll have a catch pan for that magnetic feeder to keep
To
catching
just
that.
keep catching it as
So
it
we
comes
blast, it falls down, and it just gets picked right up. So the amount of grit you use is gonna be
out. Almost
reused
nothing.
and reused.
Yeah.
There's no waste.
Because of the current systems with like the wheel bearing and whatnot, there's a ton of waste.
Yeah.
Because they're just slapping it or whatever.
So, one question is, how many times can we shoot that grit through a magnet before it comes magnetized?
Oh, because it's all metal, right? If you're using like
And
paint or
if we
chalk.
do get metallized, what can we put down here to diffuse the magnetics in that grit?
I'd have to research it. There's something to that bottom pan to demagnetize the
Yeah.
metal. How hard is that to do?
I don't know, I gotta look, see, this is what I like about my job,
Right.
forever learning,
Oh yeah, absolutely.
forever learning.
Yeah. So yeah, you'd have to find some way to demagnetize the metal in the pan, if
If
it's possible.
it's possible, and
What does it take to do it?
and how many times can you shoot it around before it's so magnetized it doesn't work anymore?
Right.
We don't know. See, when you do stuff like this, you create more questions than answers at times, so it keeps the mind,
I don't know.
you understand the concept though.
Oh, absolutely. Yeah, no, that's cool. I'm actually probably tonight going to sit on Google and see research magnetism, because I deal with big magnets that suck metal out of bins before it gets, and we use magnets as triggers. If you get a piece of metal too big that's going into the chipper, it sets off an alarm, and then we shut off our whole tripper, but nothing this granular.
So what'd you go to school for?
Oh, IT. I went to school and got my CNET and DNET, data networking and computer networking. So I was like the guy that sits in the big data center and works on servers all day long. But then I fell into manufacturing and a warehouser, and I just got fascinated with process control environment, PLC, Rockwell.
Plus you get out and around.
Yeah, and I put my hard hat on this, and I'll go out there and you change a Cognex camera and a real log coming in, and it bucks different or tilts it, and you get just a little bit better cut. Seeing that is kind of cool. It's cause and effect.
Yeah,
So-
it did cause an effect.
So my background's like not like, well, I can take this apart, put it back together, tell you chipset, all that kind of stuff. I still love computers, and I can do all the networking and the